Hello, this is Eric Steinhardt, and I want to talk to you about monads. Monads are Turing machines. Here's the basic idea. Space is a network of phones. What are the phones? The phones are monads. How do we get to this idea? Let's start with a game of life and a glider. Gliders move through space. So suppose you're watching a glider move through space and you think it's a material thing. You think there's a thing, it moves like a proton or an atom or a molecule or something. So there's a glider, a physical thing, and it moves through space. Here it goes. It's moving through space, it's moved. And if you look a little more closely though, you know about the game of life, it turns out that space is made of cells. These cells are like points, right? They're, in the game of life, they're square. That's not exactly like our universe, but it'll do for now. And so there are these cells, and the cells have binary values, binary digits, 0 or 1, with 0 being off or dead, and 1 being alive or on. 0 is no energy, and 1 is a little unit of energy occupying some point in space. So space is like a network of interacting points with those little arrows indicating little exchanges of information between points. Each point sends its neighbor a 0 or 1, its own state. Now, there are diagonal arrows, which I didn't add in order to avoid excess clutter. But the idea is that space is a network of points that exchange these little 1-bit informational signals. What are the points? The points are monads. And so a monad is a little point in space. It changes according to some rule, according to some logic, according to some programming, and it interacts with all its neighboring monads. Now, there's some qualifications here. Monads don't really interact. They are sort of entangled with each other or harmonized with each other. But that's a detail that right now we can ignore. So monads are just little points in space. And these points are little computers. Monad runs a little program. It has some binary information. And what are computers? Computers are just Turing machines. And so a monad is just a little Turing machine. So if you were to look inside a monad, you would see the tape of a little Turing machine and the little Turing machine head, which starts out at some point and goes through some computations to the end. Here I have a point where, a tape rather, where there are 9 cells on the Turing machine tape representing the state of the monad and the states of its 8 neighbors. And so this one is alive, and it's got 1, 2, 3, 4 live neighbors, and so it'll be dead at the end of this little computation. So here we go. Let's summarize. Monads are point computers. Space is a network of points. Each point is a little computer. Each point is a little Turing machine. And the monads are point computers. So monads are little point-sized Turing machines. They don't really have a size. They're infinitesimal, but they're little point computers, little point Turing machines. And that means space is just a network of these entangled point computers. Space is a network of monads. Back to the original idea, monads are little point phones, little point-sized smartphones that can be entangled with each other. In other words, information about one tells you about what's going on the others. And it's fine for us to think that that's just some kind of interaction through exchange of signals. So space is a network of phones. And that's the idea behind the monadology.